So this last, hopefully short section of chapter 16, we're going to talk about normal motor control. So we've sort of talked about abnormal motor control, and the only learning objective for this section is to list and describe the 3 fundamental types of movement. So in normal actions, feed forward from the sensory system and feedback from the central nervous system interact to create and adjust movement. Feed forward consists of anticipatory motor impulses that prepare the body for movement, and feedback is about the state of the system. So the 3 fundamental types of movement include postural, which is controlled by brainstem mechanisms, ambulatory, which is controlled by brainstem and spinal regions, and reaching and grasping, which is controlled by the cerebral cortex. So all regions of the nervous system contribute to each type of movement. Postural control provides orientation and balance. Orientation is the adjustment of the body and head to vertical, and balance is the ability to maintain the center of mass relative to the base of support. We've been talking about that since day 1, right? Postural control is achieved by central commands to the motor neurons. The central output is adjusted to the environmental context by sensory input. That's that feedback. Sensory input to the postural control, we use 3 senses to orient to the world. Somatosensation, providing information about weight bearing and relative position of body parts. That's that conscious and non-conscious proprioception. Vision provides information about movement and cues for judging upright. And vestibular, which informs a person about head position relative to gravity and about head movement. So the way that I describe these to patients, I say eyes, ears, and feet. 3 sensory inputs to posture are eyes, ears, and feet. Eyes is your vision, ears is your vestibular system, and feet is your somatosensation. For ambulation, all regions of the nervous system are required for normal human ambulation. The cerebral cortex provides goal orientation and control of ankle movements. The basal ganglia govern generation of force. The cerebellum provides timing, coordination, and error correction. Sensory information is used to adapt motor output appropriately. During normal gait initiation, the swing limb first pushes downward and then backward against the support surface. The pattern of force results in the center of mass being moved forward and onto the stance leg in preparation for foot off, and increases the magnitude of the subsequent movement. So yeah, sure, it sounds simple, right? But it requires all that nervous system input in order to do it, which is why we're so often doing gait training in physical therapy. So one little thing goes wrong, you got to fix it. For reaching and grasping, we need vision and somatosensation. Vision provides information for locating an object in space and assessing its shape and size. Feed forward is the primary role of visual information. If the movement is inaccurate, vision also guides corrections. The action stream flows from the visual cortex to the posterior parietal cortex. Grasping is coordinated with activities of the eyes, head, proximal upper limb, and trunk. Orientation and postural preparation are integral to the movement. When the object is contacted, the grip force adjusts quickly, indicating feed-forward control. After the object is grasped, somatosensory information corrects any error in grip force. So it's like when you try to pick up something that you think is really heavy and it turns out it's light. Whoa, you pick it up and it's a lot lighter than you thought, and your somatosensation has to give you the information to correct that. So for normal movement in the motor planning areas, control circuits and descending tracts have to act in concert with sensory information to provide instruction to the motor neurons. Basal ganglia receive most of their input from the cerebral cortex, and influence on movement provided by the cerebral cortex, the PPN, and the reticular formation. So lots of input for normal motor control.